Thanks everyone for participating in this symposium. That is always a really wonderful event. I'm looking forward to sharing with you some insights from the most recent round of IPCC assessments. But I want to start out with a quotation from a Department of Defense document that was just released yesterday. This is the Department of Defense 2014 Climate Change Adaptation Roadmap. And in the foreword, Secretary Hagel says, "In our defense strategy, we refer to climate change as a threat multiplier because it has the potential to exacerbate many of the challenges we're dealing with today, from infectious disease to terrorism. We're already beginning to see some of these impacts." And that really, really nicely underscores the kind of messages that I want to talk about today and the messages that come through very clearly in the assessments of the IPCC. Most of you know that the IPCC, the Intergovernmental Panel on Climate Change, was founded as a unique partnership between the world's governments and the scientific community more than 25 years ago. And through a series of major assessments over that period, the IPCC has really been definitive in characterizing what we know and what we don't know about climate change impacts that have already occurred, about risks going forward, and about prospects for solutions. There are needs for lots and lots of different kinds of contributions to assessment, but the IPCC is uniquely successful in a couple of ways. First of all, it's uniquely successful in the care and attention to detail that goes into the assessments. It's uniquely successful in the comprehensiveness and the diversity of the viewpoints that are reflected. And probably most important, it's uniquely successful in the extent to which there's really co-ownership of the assessments involving essentially all of the world's governments. I've been very fortunate over the last several years to serve as co-chair of the working group that's focused on impacts, adaptation, and vulnerability. And what I'd like to do today is summarize the full sweep of the 2013-2014 IPCC assessments, but with a focus on the area of impacts, adaptation, and vulnerability. Essentially, why is it we care about climate change? And the framing I want to start with is one that recognizes that risk of climate change impacts isn't just about the climate changes. When we think of risk, and for most people, risk is something like the probability of an event occurring times the consequences, and we care as much about low probability, high consequence outcomes as we care about high probability, medium consequence outcomes. The risk of climate change impacts really comes from the overlap of three very different kinds of things. The physical triggers, the hazards, are the high temperatures, the heavy precipitation, the extended droughts that are the physical prod to the system. But you don't have a risk of impacts unless that's coupled with vulnerability or a lack of preparation, an exposure, or the presence of important assets that are at risk. And it's really only when you have the overlap of these three different kinds of factors, hazard, vulnerability, and exposure, that there's a meaningful risk of impacts from climate change. You can think of this as a characterization of the problem space. Part of the problem is in the physical side, but part of the problem is in the social and economic side. As we move through the material today, I'll also transition to a characterization of how this representation can also be viewed as a picture of the solution space, because in each of the elements there are prospects for making improvements and really solving the problem. There are at least 5 reasons that it's useful to think about climate change as a problem in managing and reducing risks. And these paint the way not only to understanding the problem, but also to understanding the solution. The first reason that it's important to understand climate change's challenge in managing risk is that it provides a natural connection between our current experience with climate variability, which we know we're not doing all that well with, and with climate changes in the future. Essentially, there's a continuum between experience with climate that we encounter now, some of it's due to climate change, some of it's just due to internal variability in the system, and where we're headed. Second major reason it's important to understand climate change, the challenge in managing and reducing risks, is that much of the issue with climate change comes in extremes. It comes in the high temperatures, the heavy precipitation, the extended drought. whether or not climate change is causing those extremes. And understanding the risk from extremes connects us not only with the present, but it opens the doorway to understanding consequences of changes in extremes in the future. A third motivation for thinking about climate change as a challenge in managing risk has to do with the fact that we don't know exactly where we're headed with climate change. And one of the things that we want to be sure of is that we're sensitive to the full range of possible outcomes. It may be that the most likely projections turn out to be more serious than we actually encounter, or it may turn out that they're less serious than we actually encounter. What we want to make sure is that we're prepared to deal with the full range of possible outcomes. A fourth motivation for thinking about climate change as a challenge in managing and reducing risks is especially relevant to the GCEP community, because when you look around organization of society, families, institutions like universities, private sector governments, what you see is a pervasive use of sophisticated tools for understanding and managing risk. You know, at the level of a family, it's a decision about when you buy a vehicle, how many airbags does it have, how much emphasis do you put on anti-lock brakes. At the level of a firm, it's hedging strategies, infrastructure investments. And the level of a government, it's investments in defensive posture and long-lived infrastructure. A wide range of tools are available for understanding and managing risk, and those are exactly the tools that can be applied successfully to understanding and managing the challenge of climate change. And then the fifth reason it's important to understand climate change's challenge in managing and reducing risk traces back to Secretary Hagel's comments about a threat multiplier. We really don't see new kinds of problems on the local or the international scene as a result of climate change. What we see is new dimensions, new complications, new reasons for urgency associated with often long-standing problems in the social, environmental, economic dimensions. So with those 5 motivations for understanding and processing climate change's challenge in managing and reducing risk, I want to move into where we are in our overall understanding of the climate challenge. The IPCC states it that warming of the climate system is unequivocal. No doubt that in the last century we've seen a warming of a little less than 1°C, warming across the land and the ocean. In fact, if you look at all the land areas, there's only one spot in the entire global land area where there's not clear evidence of warming, and it's essentially over Washington, D.C. Not a policy comment, but that's the only place where there's uncertainty about warming that's occurred to date. In California, we've seen a warming that's more or less at the global average. If you look at where the heat has gone in the global system over the last 45 years or so, what you can see is that the vast majority of the extra heat that's gone into the Earth system has gone into the oceans. The amount of extra heat in the atmosphere is the tiny little purple slice across the bottom of that figure. And one of the things you can see is that since 2000, when warming in the atmosphere has not been profound, the amount of heat accumulating in the system has continued to increase very rapidly. But more of the heat has showed up in the oceans than during earlier periods. And the science for that isn't completely understood. It's one of the things that we really need to get a better picture of. And if you look around the world, what you can see is that there are impacts that have already observed, been clear on atmosphere, land and oceans, extreme events, water cycle, the cryosphere, and sea level. There's the point now where we can say that human influence on the climate system is clear. It doesn't even really need to be qualified with statistical uncertainty. There's essentially no question that humans have modified the climate system. The IPCC conclusion is that it's extremely likely, at least 95% likely, that most of the warming since the middle of the last century is a consequence of human actions. Sadly, I already spoke to the fact that greenhouse gas emissions have continued to increase. One of the big challenges we face is that strong connection historically between economic growth and greenhouse gas emissions, and that's driven a pattern that has been remarkably persistent over many decades. One of the big surprises is that as we've gotten more serious about discussing the climate challenge, we've actually seen an increase in the rate of emissions growth. If you look at this plot that starts in the 1970, what you can see is that from 1970 through 2000, emissions growth was about 1.3% per year. Since 2000, it's been substantially more rapid than that. If you look at the atmosphere, 2013 was the largest increase in CO2 concentration of the atmosphere since the beginning of the Industrial Revolution. Since 2007, emissions in the US had been going down, largely as a consequence of increasing penetration of natural gas in the electricity generation sector. But for the first time since 2007 and 2013, US greenhouse gas emissions went up again. We're definitely not seeing things being in the direction of really getting control of the problem. And this sets a challenge for coming up with solutions that means we're not talking about decreasing the rate of emissions growth. We're talking about slowing, stopping, and reversing. You can divide the problem into four big components. These are the components of the Kaya identity. What are the energy per unit of CO2? What's the amount of GDP per unit of energy? What's the amount of GDP per capita? And what's the size of the human population? And when you look at the contributions of each of these four factors to emissions growth over the last 50 years or so, you can see a pattern where population and GDP growth have always pushed emissions up. And during some periods, the energy intensity of GDP and the carbon intensity of energy have acted in the opposite direction. Essentially, what we need to do to solve the problem is have the savings due to energy intensity of GDP and carbon intensity of energy be larger negatives than the population and per capita GDP growth. And what you can see is that they never have been, the nets or the diamonds. And a frustrating feature of this plot is that over the most recent decade, the pattern has actually reversed such that we're now seeing increasing contributions of the carbon intensity. Essentially, there has been worldwide a renaissance in coal such that the amount of carbon associated with each new increment of energy is going up rather than down. So there's really a big problem, a very steep hill we need to climb if we're going to get ahead of the problem. I want to transition now to talking about where we are in our understanding of climate changes that have already occurred. And until the most recent IPCC reports, there was a general conclusion that there were very likely impacts of humans caused climate changes on biological and natural systems. We've now reached the point where we can identify with a high level of confidence individual impacts spread around the world. Way to say it is that impacts of climate changes that have already occurred are widespread and consequential. We've seen impacts on every continent, impacts on the oceans, impacts from the equators to the poles and from the coast to the mountains. Here's a map of the kinds of impacts we've seen. We've seen impacts on physical systems, on biological systems, and on human systems. And those have occurred in very different settings in very different places. Let's zoom in on North America. And let's talk for a minute about California and the kind of impacts that have been attributed. The clearest impacts we've seen in California have been on water resources, in the physical domain, in the biological domain. The impacts on wildfire are really clear. And in the human domain, we're really starting to see impacts on agriculture that are very widespread. And let me provide an example from agriculture that gives a little better insight into the way we understand these impacts. And a lot of the analysis that I'll present in the next slide is a result of work by David Lobel in the Department of Environmental Earth System Science here at Stanford. Most of you know that increasing yields of agriculture have been one of the great triumphs of the human enterprise over the last century. Over the last 60 years, we've seen consistent 1% to 2% per year yield increases across the board and around the world. What we're seeing now is that over the last few decades, there's a clear signal impacts of climate changes that have already occurred have made it more and more difficult to increase agricultural yields. You can think about climate change as increasingly acting on an anchor, making it more and more difficult for farmers, crop technologists to increase ag yields. The pattern so far is that this effect on yields of wheat is about 2% per decade, and on corn it's about 1% per decade. Really clear signal, and it's not that the yields are going down, it's getting more and more difficult to increase yields to meet the food demands and the fuel demands of the future. I want to turn now and talk for a couple of minutes about the other components of the climate risk, in particular the vulnerability part. You know, for a long time, we've understood that poor regions face particular challenges with vulnerability. A lack of resources, weak institutions, poor governance, all those make it really difficult to cope effectively with impacts of a wide range of environmental stresses, including climate change. And there's no question that the challenges of vulnerability in the developing world can be really acute. But an insight that comes through recently with a real starkness is that vulnerability isn't limited to just the poorest regions of the world. You look in the rich regions, this is a picture of New York City following Hurricane Sandy, is that there's vulnerability everywhere. And in some cases, the vulnerability is a consequence of not thinking the extremes could be as powerful as they are. In other cases, it's a consequence of just not having thought through all the steps that are required for effective coping with variability, whether or not it's due to climate change. But it's clear that if you look around the world, there's no place that's comprehensively prepared to deal with the changing climate. We are, however, beginning to see some really interesting and productive investments. 5 years ago, you couldn't really say that climate change adaptation was being deployed in an ambitious way anywhere. But I already read to you from the Department of Defense's 2014 Climate Change Adaptation Roadmap. We're really seeing increasingly serious investments in climate change adaptation. Essentially, every country in the world now has some kind of climate change adaptation plan in place, and we're really beginning to see real investments. This is a photograph of a flood barrier in Rotterdam, high-tech engineering solution that's explicitly intended to deal with climate change. But we're also seeing lots of investments that in many ways are even more ambitious occurring at the community level. Here's a photograph of planting mangrove seedlings on the island of Tuvalu to provide coastal protection against rising seas. There are lots and lots of examples that are beginning to be established, and it's not that we know enough that these adaptation examples are really solving the climate problem, but they're providing a rich foundation for research, understanding what works, what doesn't, what we need to do better, and where we need to do more work. I want to transition now to talking about projected impacts in the future, and there's a really simple message that you can take home about impacts in the future, and it's that the more you change the climate, the greater the risk of impacts that are widespread, severe, pervasive, and irreversible. I want to provide some background to that, but it's important to recognize that there's no evidence of a bright line. I've already described how impacts that have already occurred have been widespread and consequential. And I think much of the climate debate in the past has been conditioned on this idea that there was some safe level of climate change. It's not that there's a safe level of climate change, and it's not that there's a gigantic threshold where we transition from safe to dangerous. Here's a way to think about where we are in the trajectory of climate change. In the top panel, you can see the black squiggly line is the temperature trajectory at the global scale over the last century. The red plume at the top is potential temperature trajectory for continued high emissions. This is a trajectory that ends the century at about 4 degrees above pre-industrial and the most likely outcome. And the blue plume at the bottom is a plume with ambitious investments in mitigation. This is one that ends the century at about 2 degrees over pre-industrial. and represents, well, I'll talk more about it in a few minutes, but a really heavy lift in terms of commitment to dealing with climate change. And I want to emphasize these two possible worldviews, not because these are the only two we should consider, but because they represent useful bookends about possible ways things might unfold in the future. And when you look at the next century, it's important to recognize two really different eras. Where you see the black arrow now, you can think of this as well, I call it an era of climate responsibility. And what you can see is that independent of investments in mitigation, there's not a big difference in the temperature trajectory over the next few decades. Basically, temperature changes and climate changes during that period are more or less baked into the system. They're baked in partly as a consequence of the physics of the way the climate system works, but they're baked in partly as a consequence of the persistence of the technology infrastructure that we depend on. There's no way that we can immediately stop emissions, no matter how much we want to. It's also an era of responsibility, however, in the sense that if we are going to be on a trajectory of ambitious mitigation in the second half of the century, we need to make the investments in the next few decades. And I'll talk more about the timing as we go along. But in order to be on the trajectory of ambitious mitigations, the only opportunities for doing it in an economically efficient way come up with investments in the near term. So in the second half of the century, what you can think of as the era of climate choices or climate options, we really need to be making decisions now that change the trajectory of the curve. The bottom, you can see two maps. These are maps of the end of the century temperatures for the world of ambitious mitigation on the left-hand side and the world of continued high emissions on the right-hand side. And I want to juxtapose those with the map of the climate changes that have already occurred using the same scale. And what you can see is that in the 2C world, the world of ambitious mitigations, the amount of temperature change in the future is more or less the same as the amount of temperature change we've already seen. It's enough to generate important new risks. It's enough to generate important concerns and investments in adaptation, but adaptation is a powerful set of tools for dealing with the world of ambitious mitigation. If you look at the panel on the other side, the world of continued high emissions, where we end the century with a CO2 concentration of something like 1,000 parts per million, where we're looking at a warming of something like 4C over pre-industrial, you see that most land areas have warmed more than 5C. And when we try and study impacts in that world, it's a very frustrating endeavor because it's so different than the current world that it's very difficult to come up with any kind of a meaningful study. You know, the way I characterize it is that we can provide some very rough characterizations, but in many ways, the nature of the impacts in that world is that all bets are off. Let me try and provide just a little bit more definition to where we understand the options for characterizing impacts and the way those impacts change with temperature. In this figure, the left-hand panel is the one you saw before. It characterizes the world of continued high emissions with the red plume and the world of ambitious mitigation in the blue plume. And when you think about impacts of climate change, you can really divide those into a small number of baskets. One of the big challenges we face in dealing with impacts of climate change is that there are thousands of possible impacts, tens of thousands of possible interactions among impacts. And what we'd like to do is have some kind of a systematic way to sort those and recognize that stakeholders in different parts of the world will value them very differently, that different parts of the world will be subject to these impacts in very different contexts and settings and levels of severity. So among all the IPCC authors, there's a appreciation that a small number of different kinds of baskets of impact can be a very useful way to frame the problem. And this figure is called Reasons for Concern or Burning Embers, really traces to the late Steve Schneider a brilliant insight about the fundamental non-comparability of different kinds of impacts. The rightmost column is impacts on unique and rare systems, and things like unusual species, archaeological sites, historical sites. We've already seen some species extinction, so we know the risk is already beginning to increase for rare and unusual systems. The second bar is extreme events. Increasing evidence for a role of climate change in extreme events, and many of you probably saw the news in the last few weeks based on studies of Daniel Swain and Noah Diffenbaugh here at Stanford about the changing probability of a drought like we have in California as a consequence of the climate changes that have already occurred. Clear that extreme events are very difficult to juxtapose with other aspects of climate change impacts, but really, really important. The middle bar in this figure is labeled distribution of impacts. I think of it as the unfairness aspects of climate change and the fact that many of the most profound impacts occur on individuals and ecosystems that have contributed the least to the problem. Very difficult to come up with a systematic way of evaluating those distributional factors, but almost everybody agree that they're important and ought to be a part of the package. The fourth bar is one that's labeled global aggregate impacts. These are the ones that fit easily into the integrated assessment models. You can think about them as impacts on the global economic output, total amount of fresh water, total food supply. And we're less clear that impacts at this global aggregate scale have already occurred. I showed you some evidence that we're beginning to see impacts on food. But the distinction, the contrast between when risks start occurring in these global aggregate impacts and some of the other areas is really stark. The final bar is called large-scale singular events. And that has to do with the increasing evidence from the physics of climate change that there are some important thresholds. And the threshold that's most important and nearest to us is commitment to irreversible loss of a major continental ice sheet, the Greenland ice sheet in particular. Greenland ice sheet contains about 7 meters of sea level equivalent. All the climate change evaluations are that irreversible commitment to loss of the Greenland ice sheet occurs at a warming of somewhere between 1.5 and about 3 degrees C above pre-industrial. And even though that warming occurs, or that melting occurs over several centuries, once we're committed, we're really committed to it. And the prospect of altering the trajectory of the melting once it's committed is very, very slight indeed. So if you look across these 5 reasons for concern, you can see a picture of the way that with different value systems, different stakeholders might prioritize climate change differently. You can also see the contrast in the risk level between a world of ambitious mitigation, a world where we're at something like 2C above pre-industrial at the end of the century, and a world of continued high emissions where across the full suite of the impact areas, the reasons for concern, we're looking at risks that are high to very high by the end of the century. There's no question that there's a big difference in the level of risk between the world of ambitious mitigation and the world of continued high emissions. Probably the most consequential difference is that with the world of ambitious mitigation, there's a wide range of opportunities for investments in adaptation that are likely to be successful. With the world of continued high emissions, the physics, the biology, and the economics show strong indications of being overwhelming the prospects for adaptation. And at least for me, that's the real dividing line between a world of ambitious mitigation and one of continued high emissions, is whether or not there are prospects for adaptation. So what can we do about it? There's no question that changing the direction of society, of emissions, is a big lift. The wording in the IPCC report is that limiting warming to 2C, or whether it's 2C or 2.5, doesn't really matter. It involves substantial economic, institutional, and technical challenges. And here's a way to see the magnitude of those. The plume here indicates a world of continuing high emissions, meeting the energy needs of the world's people in a way that Sally described, but not paying attention to climate. And that's contrasted with a world where warming is limited. Here you can see to 2C or 3C in a way that also meets the growing demands for energy. If you look at the 2C trajectory, you see a really striking pattern, complete decarbonization, such that at the global scale, emissions worldwide reach zero in the later decades of the 21st century. And in fact, the average across those 2C trajectories is negative across the whole economy for the last couple decades of the century. But another striking feature you see if you look at the 3C trajectory is that that looks very similar to the 2C trajectory, just with changes that are occurring a couple of decades later. So whether we're aggressively pursuing a target of limiting warming to 2C or a much looser target of 3C, we're still talking about very comparable changes in the nature of the energy system, comparable changes over the 21st century, with the only real variable being the timing. But there's a wide range of good news aspects as well, and that's what I'd like to talk about just in the last couple of minutes here. So one piece of really interesting news is that an increasing fraction of emissions are now covered by some kind of agreement. In fact, in 2014, over 2/3 of global emissions are covered under some kind of agreement. Now you could say, well, you just showed me that emissions were increasing faster than ever before. How can that be good news? And it's clear that the agreements don't have the teeth they need to be effective, but at least there is a skeleton of agreements in place, and the challenge isn't coming up with covering more and more of the emissions in the short term. It's figuring out how to make the agreements that are already in place more effective enough that they really begin to bend the curve. At least for me, the most encouraging aspect of the full set of IPCC reports is a recognition that if we look at the challenge of sustainable economic development, the challenge of climate change adaptation, and the challenge of climate change mitigation, that those don't really need to be understood as competing agendas. There are many opportunities for linking the goals of sustainable development, of climate change adaptation, and climate change mitigation so that they're complementary, so that the emphasis is on co-benefits, on low-hanging fruit, and on the way I think about it is building robust economies and vibrant communities. And I want to say just a few things about the way that might come together. I characterize this as a picture of the problem space when we started out, but now I want to explain how it's really a picture of the solution space and how every element that represents a problem in the world of climate change opens the door to opportunities for solutions. It's clear that mitigation has tremendous potential, and most of what you'll hear over the next few days here at GCEP is going to be about mitigating climate change, providing energy services without the CO2 emissions. It's clear that there are lots of things we can do to deal directly with vulnerability and exposure. There doesn't have to be a one-to-one link between economic growth and increasing vulnerability and exposure. Smart processing of the economy and smart processing of development can increase opportunities for people at the same time they decrease vulnerability and exposure. Another set of opportunities has to do directly with the elements of decreasing risk. We tend to think about risk management through vehicles like insurance, but there are lots of pathways for increasing risk perception, dealing effectively with all the dimensions of risk in preparation and response that let us deal directly with some of the outcome side as well as some of the income side. If we look at socioeconomic pathways, we know that there are things that need to change, but there are also a wide range of opportunities for building more equitable, more efficient, more functional economies as a result of co-investments in climate change at the same time we're dealing with other things. We know now that adaptation and mitigation don't have to be competing agendas, that adaptation and mitigation can be reinforcing, and in fact, investments in one can simplify investments in the other. And then finally, there are lots of opportunities for taking advantage of investments in dealing with climate change to strengthen institutions and governments. What does that lead to in terms of the specific opportunities, the kind of opportunities that the GCEP community can deal with? You know, in the IPCC, it's not really our job to try and identify winners and losers in terms of the technology space, but the integrated assessment models provide a wide range of possibilities for where investment flows might go, and with a, let's say, idealized understanding of what's economically efficient, you can see two things. You can look at a chart like this and say, wow, we're going to have to spend vast amounts of money to solve the problem. Or you can say, look at the magnitude of the opportunity in some of these technologies. Look, for example, at the energy efficiency bar. That's saying over the next few decades, we're looking at a need for income flows to energy efficiency of order $350 billion a year. Immense opportunity. And if you look across the spectrum, solar electricity generation, renewables, nuclear power plants with CCS, all represent huge investment opportunities. And that's the message I really want to leave you with. It's important to recognize that climate change really is a challenge in understanding and managing risk, but it's also a challenge that's ripe with opportunities for creative individuals, creative companies to effectively pursue solutions. I want to close with a cartoon from Tom Tolles, who represents as far as I'm concerned, the pinnacle of effective communication on climate. And he really nails the essence of the challenge and the essence of the solution in this cartoon. So this is a scientist in 2060. I hope it's not me. And they're still searching for the solution to the climate challenge. And they finally have it. And in this cartoon, it's a time machine taking people back to 2010 when they should have gotten their act together to solve the problem. So we may come up with a time machine, but the message I want to leave all of you with is that you shouldn't count on it. And we don't have to count on it if we're smart about the way we deal with the problem. Thanks very much. I think I still have a few minutes for questions.
We have time for questions. So so questions from the audience.
And I think there's a roving microphone, so if you wait till a microphone appears.
Chris, I know this isn't really your bag, but people don't seem to talk much about population. If you look at the UN population forecasts of 15 years ago, they projected 1 billion less people in 2050 than they project now. So if you also look at your charts on GDP per capita, this, that, and the other thing, clearly population is one of the big drivers of emissions. Now, has there been any thought on what one might do to start bending the population curve as well as bending the emissions curve?
It's a great question, and there have been some studies that have said, what's the cost effectiveness of meeting existing demands for family planning services? And the consistent conclusion from those studies is that the cheapest thing we can do to reduce emissions over the next century is to meet the existing demands for family planning services. No question that that's a real opportunity, but it also is important to recognize that that's not the only element, the problem that needs to be addressed.
Okay, we had one over here, and then we'll go back to the middle of the room.
The question was on cost. Could you put integrated cost curves on top of the temperature graphs so that it might show what happens if we wait 10 years and we miss the Paris opportunity, just like we missed the Copenhagen opportunity to some extent?
Yeah.
Show what happens if there's overshooting.
Yeah.
To catch
So
up and
I can't give you the numbers in terms of cost, but I can frame it in terms of how fast emissions have to decrease. And if action to do ambitious mitigation comes online in the next 10 years or so, after 2030, we're basically looking at emissions decreases for a 2-degree target of about 3% per year. If by 2030 we're still emitting the current 50 gigatons of CO2 equivalents per year, we're looking at the second half of the century of having to decrease emissions at 6% per year. 6% per year is, I don't know, it's really hard to imagine thinking of that rate of decarbonization.
Okay, over here.
Yeah, the committee rightfully looks at emissions of CO2. But there's another component to this, and that's what's already been emitted. And there's a tremendous amount of CO2 in the atmosphere and a tremendous amount of CO2 in the oceans. And indeed, there's evidence that we're changing the chemistry of the oceans to our detriment. Is there thought about the mitigation process in the oceans?
So for every ton of CO2 that's emitted to the atmosphere in the long term, about 80% of it ends up in the ocean. That we know is making the oceans more acid, and we've seen impacts already. One of my colleagues at Carnegie just published a study showing that since the 1970s, rates of coral skeleton formation have already decreased by about 40% as a result of the increase in acidity that's already occurred. The prospects for, well, so there are two elements that you can think about pursuing for mitigating ocean acidification. One is decreasing emissions, as we've already talked about. The other is removing CO2 from the atmosphere, as Sally already mentioned as a possibility. You'll hear through the session over the next couple of days where the science is in terms of prospects for removing CO2 from the atmosphere. Most of the analysis in the IPCC report has focused on the process called biomass energy with carbon capture and storage, which is likely to be relatively inexpensive but has a relatively limited scope. And then the other option is air capture, which looks at this point like it'll be really, really expensive. In general, more rapid introduction of renewable technology is going to, looks like it'll be cheaper than widespread deployment of the CO2 removal technologies.
Okay, more questions. Oh, we've got one here.
Your projection for the increase in greenhouse gases, what is your assumption on methane?
There are a wide range of different assumptions on methane, and most of the assumptions about methane are based on the idea that we're not going to do anything dramatic about methane releases from wetlands or from agriculture, but that we will be increasingly effective at preventing fugitive losses of methane in the energy system.
Okay, we have time for one quick question. Yeah? No? Any more? Oh, yeah, we've got one here. Dan.
I did.
Hey, Chris, after having just fought the AR-5 battles, do you want to comment on what's needed for AR-6?
Well, let me just return to the point I started with, and it's that IPCC is not well prepared to tackle every aspect of the climate assessment problem, but it really provides unique value, and I think the greatest value comes in the carefulness with which the assessments are done and the government ownership, so that it provides essentially a foundation on which all the other assessments can build. And I hope that it can continue to provide that kind of a solid foundation that encourages a real flowering of other assessments that build local scale or process scale information.
Okay, with that,
Thanks
I
again.
think we need to move along. Thank you.